Policy and Project Officer in EURADA, and I will be your moderator for today's event. A few things to note once again before we begin. Please make sure that your microphones are muted and that you are in listen-only mode to avoid sound interferences while the speakers are talking. Please also note that this webinar is being recorded and will be published at EURADA's YouTube channel later in the week. Finally, please do not hesitate to send us your questions for the speakers after their sessions. You can do this through the chat box of the platform. So today's webinar features the Techmeter Regional Analyzer, which is an interactive big data application. It is aimed at helping regional development agencies track the success of smart specialization initiatives by providing live dashboards with key metrics needed to help high-impact action plans. Now, as regional development practitioners, I'm sure that this topic is of great interest for all of us. Aside from further discussing the support mechanism offered by the Techmeter Regional Analyzer, we will also be guided as we explore the demo account prepared by the Techmeter team. To remind you guys, this demo account is available in the link, which has been shared in the comment in the chat box section. So if you could click that link, and the following login details will be required. So I am sharing them with you right now. So I hope that you are all opening the link because this will be used by our first speaker. So I'd like to introduce Dr. Manfred Stadelbauer. He graduated with a degree in chemical engineering from the Johannes Kepler University in Linz, where he also pursued an MBA in finance management and afterwards a PhD in chemical engineering. He has invented 20 worldwide patent families in the field of material science and processes, and on top of that, he is the founder of Techmeter. So we have the best person to tell us what exactly the Techmeter Analyzer is and how it can help regional development agencies. Mr. Stadelbauer, I turn the floor to you.
Thank you very much. Good morning. It's a big pleasure for me to get the space to share with you one of our products supporting smart specialization strategies. My name is Manfred Stadelbauer. I will take you through a couple of introduction slides in the next 10 minutes or so, and the main part of the presentation will be about demoing the portal as it is. At the end of the presentation, after the summary, there is a lot of room for questions and answers. Nevertheless, I really invite you, if you have an open issue during my introduction, please don't hesitate to interrupt me so that I can answer the questions straight now. But at the end, there is also a lot of time. Basically, what we have developed is a set of tools supporting development agencies with some essential information tracking output variables of regions. It's very much focusing on technologies, and it provides insights in the technology strengths of regions. Our regional granularity is on NUTS 2 level. We could also do it on NUTS 3 and of course on national basis, but where we actually prefer to study the structures and the specializations on a NUTS 2 level. We look into the regional strengths, particularly on dual strengths. So where is industry strong and where is academia strong? And where do we have a match and where do we have a mismatch? Where is industry stronger than academia? Where is academia stronger than industry, in order to give a strategic directive where to set certain emphasis and certain support. It's also very much about understanding the patterns of interregional cooperations, because on the one hand, it's about strengthening competences locally. On the other side, it's about technology diffusion, and it's about interaction regionally and technically. And one of the networks we study in depth is how inventions are created over different regions. And that's something we can map and show as interregional cooperations. But not only regions are cooperating, it's also technologies which start to diffuse. There are enabling technologies which find new applications, and that's the kind of technology diffusion which we also monitor and report as networks. And we can also build global benchmarks. For example, if we see a technology diffusion taking place elsewhere than in Europe, we can show an alert and say, well, there is something going on, let's say in Asia, where certain key enabling technologies, where Europe is strong, are connected with applications we haven't seen before. So this alert system is also in place. And I'll show you that in the demo later on. We also have algorithms in place which weekly detect key enabling technologies. And we have an algorithm in place which detects exponentially growing technologies. There are alert systems around which continuously put the focus and highlight certain important technologies which get some current momentum in industrial research. We map top regions globally, so not only in Europe, and importantly, all our data contains information about the organizations behind the invention. So we can map the top universities and the top companies, again, linked to geographies. And that's basically what I'm going to take you through in the next couple of minutes. Just a quality check to Mrs. Amora. Is the audio quality fine?
We can hear you.
Thank you very much. So I proceed. So from the flow of my presentation, I will say a few words about especially why we found the motivation of Techmeter. And then I will step into the key questions we can address, which are important for development agencies. I will give an illustrative example for Hamburg. I prepared it, but this is just an illustration how such a tailored innovation portal can look like. And I will sum up with the typical deliverables for development agencies and what the benefit. Just one word, why Techmeter was founded. This is a bit curious because I was basically working in industrial research for Borealis in Linz. And we were developing new polymer structures, and we had to recruit some 200 top experts globally. And my question was how to map the structure of scientists. So how can I find central experts? And how many are they, by the way? Because this is a very specialized field. And I thought one of the most robust information sources must be patents. And from that, I basically developed at that point of time, small patent database, which was focusing on social network analysis of inventors to identify the core people which are central in the co-inventor network worldwide on topics we were tackling. And from that, everything developed, because I mean, this particular idea was never really followed, but then it turned out that the same approach works for technologies. And if you have the global technology network in front of you, you can immediately identify central technologies and go ahead. And this is an enormous predictive power. And it turned out to be a robust concept, and that's basically the idea behind. So what we are doing data mining on patents and on literature, and we particularly using methods of social network analysis to understand how the topologies develop. So it's less about the dynamics of individual technologies, which is also important, but it's very much about how do technologies start to connect with each other, because that's how new applications and new technology concepts arise. Most of the inventions is innovation from combination. So putting things which partly existed in another context, putting that together and making something new out of that. So technology diffusion, and this can be nicely mapped with our methods. And the core thing is really to use network analysis for that. Okay. So let me come to the core. What is important to look for? in the context of regional development agencies. Techmeter actually supports those innovations which are driven by regional specialization and cooperation. For that, it is, of course, important to answer some very specific questions. And the three most important ones in this context is really to have a regional benchmark of the technology strengths. And this has two dimensions. It has a strength on an industrial side, and it has a strength of the academic side. So what we're doing here is a dual strength analysis where we map the output in terms of publications from academia and patents from industry in a certain region, and we put that in connection, and we build some benchmarks over higher regions. This can be a European benchmark or a global benchmark. And from that, we first of all see how balanced are industrial research and academic research in certain fields, but we also see what's the benchmark of this output compared to the world or to Europe. So we have a benchmark and we have a balance of industry and academia. I'll show you the example in a minute. What we also do is we actually weekly run our algorithm over 90 million documents and screen which technologies are emerging. We have conducted some research on economic research actually, and we've taken a look what impact patents have on exports. And what we've seen is that on a macroeconomic scale, that 4 years after a wave of patents in a certain technology area, 4 years later, exports are starting to rise. So we have an information lead time of theoretically 4 years. If we monitor patents, 4 years later, we will see exports to grow. So what we're doing here in order to keep the information advanced is we look into the past 2 years and check the growth pattern of all possible technology combinations. This is a vast number. Also here, I will show you an example, but luckily it reduces to a more tangible number of technology clusters, which really show exponential growth in the past 8 quarters, in the past 2 years. So we still have an information lead time compared to business data of 2 years. And that's what we put in our basket of emerging technologies. Also, this set of technologies is extremely valuable because it can be mapped to key enabling technologies and future enabling technologies, and strengthen the process of focusing on certain technologies which will become important in the near future. And finally, all our data is organizationally sharp. We can look at the institutions which created the knowledge, which created the intellectual property, so we can map on a regional level the relevant universities and the relevant companies for certain technology areas. And this is important when it comes to networking regions with other regions, which are really top in certain specific technologies where experience has to be built up locally to support smart specialization from fostering cooperations with other regions. But in the first step, of course, it's important to quickly identify those regions which are really top, and to identify the organizations which are really top, because they are the ones which need to be teamed up and connected. The first important information element in our analysis is, as I mentioned before, is the dual strength analysis. The dots in the chart, green and blue, these dots stand for specific technologies. And we map the output variables from industry, namely patents, against the output variable of academia, namely publications. And from that, we derive the dual strength portfolio. For each technology, there is measured a certain industry strength, so how many patents are published in a certain technology in a certain region, and we measure a certain scientific strength. So how many publications are published in a certain region from the institutions in this region compared to the benchmark. And if we do that for a portfolio of technologies, you can see these are distributed. Some of them are more in the left top quadrant, and they stand for technologies which have a high relative scientific strength, but a comparatively low relative industry strength. So those technologies have potential for the industry to become stronger because there is a lot done at university, but only little is really materialized in patents in the region by industries. But in contrast to that, there are also other technologies like this one, which have a high relative industry strength, but little scientific output. Here, there's the opportunity to foster academia, to support academia, to fund it in certain technologies so that this gets balanced again. The balance is important, obviously, because scientific research done at academia supports the industry research, but even more importantly, it's about educating people to a sustainable portfolio of technologies, which continuously creates new scientists, new engineers, and so on. Those technologies are at the diagram of this chart, preferable, of course, on the right top, because that stands for an absolutely high output from academia as well as from industry. These portfolios are plotted for certain NUTS2 regions. The technology portfolio can be tailored, so it depends a little bit on what's the objective of the particular analysis. For the illustrative example, I will switch to in a few slides. We've just defined a very generic portfolio where we've used the CPA material classification codes just to give a very broad overview, but this can be very, very specific. We are using a hierarchical topic structure with 240,000 specific technologies. So we can really zoom into very specific things, but for the case study here, it's more generic. But for other certain questions, for example, how do certain key enabling technologies link with other technologies, it is important and it is possible, easily possible, to look at that very, very fine technical granularity. Because one thing we always have in mind is that technologies don't stand on its own. They are always connected with each other. Only rare cases of technologies have some innovative momentum just in its own. The innovative and inventive momentum almost always comes from technologies getting connected with each other. So having in mind the technology network is essential to understand innovation ecosystems and how they bring up new concepts. I mean, just some ideas to make that specific. Augmented reality itself is a technology, but it only makes sense. I mean, it creates a lot of sense if it's connected with certain applications, mobility, industry processes, and so forth. So that's the kind of connectivity of technologies we are referring to and we are monitoring in order to understand where the emerging technologies clusters arise. At this point, I would like to switch to our demo portal, where you got the link and you're kindly invited to test the system. It's basically a generic setup with a generic catalog of technologies. The login is DE60, the password is demo in small letters. And what we've done, we've defined technologies based on the CPA codes, and we've mapped the European patent output over the past 10 years, and we've evaluated this patent output for Hamburg and built the corresponding benchmarks. So the first thing you see is the dual strength analysis for the different technologies. It's plotting the technologies on the two axes, the relative strength of industry and the relative strength of academia. And it gives an interpretation on the right-hand side. So, I mean, this is interactive. I can select certain technologies, but this is now the overview. The highest strength of academia in Hamburg is in civil engineering, followed by machinery. The highest industry strength, relative industry strength is on tobacco products where there is no academic research. So if I'm curious to understand, for example, pharmaceutical products, what is happening there, I can click the node in the chart, and all the visualizations get updated for pharmaceutical products. So in Hamburg, let me go to the top again, to the overview, with certain top companies in pharmaceuticals, Henkel, Bayersdorf, Eppendorf, and so forth. And we have certain top universities which are mapped. We have a certain region-specific technology network. I will explain that in a moment, but importantly at this stage, pharmaceutical products are also linked also on this extremely high aggregation level of CPA technologies. They are not standing alone. They are also connected to certain other technology areas. And these are the lines which go out here. This picture is for Hamburg. And interestingly, one can compare the technology network. So how is pharmaceutical industries embedded in other industries in Hamburg compared to how is pharmaceuticals embedded globally? So, and that gives, of course, a gap analysis. It shows, and the potential, because that shows what other industries might be valuable to consider to connect with pharmaceuticals in this case, which Hamburg is not necessarily doing yet, or not showing it in terms of patterns. Then there is a specific benchmark analysis showing how the relative strength of Hamburg is developing in the past 10 years. It shows the top regions in Europe in pharmaceuticals, and it shows the global innovation hubs on a continental basis. Let me maybe first go to the ranking, because that's straight to explain. What it's doing is it measures the patent output in pharmaceutical products from Hamburg every year from 2010 to 2019. And it compares the patent output scaled to the population, so it calculates the patent density. It compares the patent density of Hamburg with all other NUTS 2 regions. And then it builds a rank. So the lower the rank, the better Hamburg is performing. So you see, in 2010, Hamburg was ranked number 15 amongst all European NUTS 2 regions. It improved to 14 and so forth. In 2019, it dropped a little bit and achieved a rank of 23 amongst, as I said, all European regions. So this is still a good ranking amongst the top 10%. We believe that this benchmark is an important argument. It is an important argument to show the performance of a certain region. And in connection with the technology network, because the technology network gives clear hints which complementary technologies are important for pharmaceuticals, to also attract other industries. So this is not only, it's of course important to measure the initiatives set in a certain region and to have a track record of the output variables of those initiatives, but it is also important as a selling argument in terms of attracting other industries, in this case for Hamburg. So for whomever pharmaceutical products are an important complementary technology, this is an argument why Hamburg is an attractive region to do innovation. So I said a few things about the technology network. what is done here is to map the links of pharmaceutical products with other industries. I mean, it's a bit small here on the screen, but it's interpreted on the right-hand side. Hamburg has a lot of interdisciplinary cooperations, especially with courier services, with machinery, with textiles, with tobacco products, and so forth. However, if I compare this picture of Hamburg, so how are technologies connected in Hamburg, how is co-innovation functioning, and how is the ecosystem functioning in Hamburg compared to the global ecosystem? So how are patents, how interdisciplinary are the patents globally in pharmaceuticals? We see that there is much more on mining, also on forestry, and so on. And these are some opportunities in terms of strengthening interdisciplinary cooperation. This is also here summarized at the bottom and interpreted. And this works interactively for any technology. So if I'm interested in, for example, furniture, I find curious. So let's click on furniture. I get the same picture. And yeah, again, I mean, of course, it's interesting because furniture, you would think about something traditional, but in fact, chairs for an airplane and so on, they are also part of furniture. So Airbus is the top company in terms of furniture in Hamburg. And here again, you see the opportunities to connect furniture in Hamburg and so on. And another, so this was basically two information elements. First of all, how well is the industry and the academic output on certain technologies in one particular region in Hamburg. This works for any region, of course. The second information is how are technologies interlinked with each other. We have a benchmark how the output performance is. But there is yet another, and probably the most important aspect, and that's the interregional connectivity. So here I still have the example for furniture, and this is the map of the NUTS2 regions and how the patents in terms of furniture, which are related to furniture, how they are invented on an individual inventor base. So this maps where are the brains sitting, because patents are almost always created by more than one person. And these persons, they might be at one specific place, but they are not always. And what's mapped here is whenever co-inventors, different inventors of the same patent, are living in different NUTS2 regions, this is plotting a line. And as you can see, there is some pattern here. Why is it important to look at the people rather than the organizations? I mean, international companies, they tend to have some headquarters somewhere, but they tend to have an awful lot of more places where they do research. And what we want to know is where is the research happening. And here we look at the people because they are living there and they have a very small, I mean, compared to industry, they have a small radius where they travel to their place where they actually invent things. So we are mapping inventors at this stage, and we can see how the regions are connected from co-inventors. This chart is interactive, so I can click on one region, for example, Techmeter in Germany, and I can see the companies working on furniture there. I can also click here, I can look which are the top regions in furniture. It's actually an Austrian one, Vorarlberg, and I have the companies working in Vorarlberg with the metrics, the number of patent applications in Vorarlberg, the number of inventors, the NUTS2 network density. What does that mean? How many NUTS2 regions are connected with Vorarlberg, for example? So it's 19. Let's look at, for example, the Irish region. It has a network density of 18 with a list of companies and certain institutions. On the right-hand side, it gives us a certain interpretation from the perspective of Hamburg. The most co-inventors of inventors in Hamburg are in German regions, in Schleswig-Holstein, Lüneburg, and Dresden. But there are There are also a lot of cooperations with Zurich going on. I can click Zurich then and get a list of the companies active in some fields of furniture in the region of Zurich. So it gives, on the one hand side, it gives the ranking, which are the top regions in furniture, and it gives an information about existing corporations of a certain region, in particular of Hamburg. This chart is particularly important when it comes to setting up, of course, new corporations and keeping track of existing initiatives again. Because with a few clicks, you can see the most active institutions in terms of companies as well as universities in certain technology areas, which might be important because they are connected with a certain field of strength of the own region, or because they show a particular dynamic or whatsoever. I should mention that the granularity of topics, of course, determines the information one can gain from such an innovation portal. The finer the granularity, the more detailed the answers will be. If I go at the technical granularity, like for example, augmented reality with certain other applications, then I get a very specific picture. If I go on a very high granularity, as it's done here, you get more a kind of an overview, which are the really big industries of certain regions. And so it depends a little bit on the question and the objective, how to set up such a portal. But if it goes towards an overview, the CPA terminology is, for example, a suitable one. So what this portal essentially delivers, just to kind of wrap up in the middle, is it provides some robust technology strengths and benchmarks, and it's really referring to some robust base data. Because if we look at patents, if we look at literature, this is an extremely robust information source where one can really go into discussion and also drill further in detail, because there is a lot more of information in patents and in literature than just the metadata we are showing and highlighting here. Where is it, and so on. There is a lot of connectivity which is evaluated, and there is a lot of technical information underlying here as well. But essentially, as an overview, we can derive what are the key technologies of a certain region, and in which technologies is the inventor density highest. And we create some benchmarks with other NUTS 2 regions or with other nations. In the second important point, we can identify complementary technologies. This can be on a highly aggregated level, so basically complementary industries segments, but it can also be very fine granular on specific key enabling technologies. So whatever is of relevance. Importantly, we keep track of emerging technology clusters. I will show you that in a minute. And we, as an output, we create inventories of technologies which can create most synergies with the local strengths. So we have two baskets basically. We have a basket of global emerging technologies, and we have a second basket of regional technology strengths. And we can make a matching of what is globally emerging and what is locally very strong, and see which technologies which are locally strong have a perfect match with globally emerging technologies. So in order to make the connections for future innovations. This is an extremely valuable approach to identify key enabling technologies which are relevant for a region, and also to identify future emerging technologies which have the potential to perfectly match with the local strength of a region. But before doing that, of course, one needs to generate these inventories and to understand where are the particular strengths, which are the actors, and whom to connect to. And finally, yeah, that's the third point already. Of course, we need this information on an organizational level in order to make it happen, to catalyze that it really happens. We need to know which universities to approach, which companies to approach in order to connect them and to generate inventions from combinations based on local strengths. I want to go a little bit back because now I've showed some output to expect, but I also want to give a little bit of an explanation because I didn't do that before. So why are patents so suitable for our approach? Because why can I say that patents are an extremely robust source? I just want to give one example that shows just the front page of any patent. Just to explain why this information in the just on the front page is so extremely valuable. I mean, it's just any patent, polyolefin foam. But in this field here, that's this patent classification. I mentioned before that we're using a catalog of 240,000 technologies, and that's basically the catalog of international patent classifications. And you can see that this very simple patent already falls into 5 to 9 different technologies. So what one can say already from this field here is that there is one patent out of 90 million which connects those 9 technologies with each other. So imagine we don't look at one particular patent, we look at all patents. So of course, if you analyze the patent classifications, you can identify the central technologies in a huge technology network because they are connected from individual documents. We can also see, and that's very valuable, the inventors together with their zip code. So we know where the inventors are living essentially, and we can plot the connection. In this case, these regions are close to each other. It's both Upper Austria. But here we could have a co-inventor in Czech Republic or in Italy or whatsoever, or in Finland. And that would show us that there is a co-inventor structure between different NUTS2 regions. And that would trigger such a connection line in the European map. In some cases, we also see that different companies, assignees or proprietors of certain inventions. That would also trigger a connection line between organizations. So and of course with a timestamp, we know when this document was published. So just from that, we have an organization, we have the inventors, we have technologies, and all this data is connected with each other. And this is the basis of our analysis, but of course it needs to be done somehow in an automated way. So from the typical project deliverables for development agencies, I would like to summarize. We are important. Wait, that was too fast. Can you please repeat that? I've seen that there was a question but it was too fast. I was too concentrated on my slides. Maybe you can ask this question later. My apologies. I haven't had the chat window open. So there is sorry for that. Just a moment. May I sum up? Mr. Damm asked, when you say mainly patents, what else do you take into consideration? Thank you for this question. Literature, to be brief. To be precise, when we look into patents, we are looking at the patent applications themselves, because the granted patents, they have too much of a time delay. Just to answer this question briefly. So patent applications and literature. A second question, how could we use in practice the benchmark with other NUTS 2 regions to establish the priorities of the smart specialization? In the example of Hamburg, does it mean that we should invest more in pharmaceutical than in coal or furniture?
Mr. Sandbauer?
Yes.
I think maybe you could save the questions for after your presentation.
Yes, thank you for the feedback. Yes, I was
thank you.
Yes, understood it. Thank you. Interesting questions. I'm looking forward to that. Let me quickly sum up before I come to one more essential and really thrilling point, namely the emerging technologies. But I want to sum up beforehand this. Typical project deliverables for development agencies. First of all, the dual strength analysis of the own region and of any other region. Dual strength analysis locally together with a benchmark over all regions. A network of technologies on different granularities, on a helicopter view, more industry segments, but also on a very specific level, to allow prioritization of certain key enabling technologies which have the strongest potential with the local strengths. And information on an organizational level, geographic, that's clear, but also organizational, which companies have the strongest output and which universities have the strongest output, to have a very tangible result of this analysis process. Before coming before finishing, I just want to share one more slide, because I always mentioned that we are so strong in detecting emerging technologies and so forth, but I did not yet explain what we're doing here and what you might expect as a result from that. And I want to use the last couple of minutes to explain that, because this is something very specific of our algorithms. But we're basically doing that every week. We get a new bunch of patent applications, and we look into this metadata element I've shown before, where I mentioned that technologies are connected from patents. This is our important field, and we look into the technology combinations mentioned in the latest patents. And we check if there is any new technology combination which has not been mentioned in the past. More precisely, we are not looking at unique events, but we are looking at groups of sufficient size, so in order to avoid some noise in the data. And we demand that the dynamics of such a group of documents which newly combine certain technology areas, that this dynamics is exponential in the past 8 quarters. And what happens if we do such an analysis is that out of 240,000 technology nodes, only 5,000 turn out to be part of exponential growing technology combinations, and that out of 28 billion or 29 billion of technology edges, theoretical edges between the 240,000 technology nodes, only 7,500 are really exponentially growing. And even more comfortable, we can cluster this picture with that's the picture of the 5,000 nodes. We can cluster it into 500 clusters, and actually these 500 clusters can be further reduced to some 40 really big clusters. So, and this picture is drawn weekly, and that is extremely important because it shows which are the central technologies in exponentially growing clusters. And while this picture is drawn for the world, you can take out this bubble and match it with the technology strengths of your region. So this immediately answers the question, which are the key enabling technologies which are highest relevant for a certain region in order to generate innovation with current key enabling technologies. That is an extremely important add-on to our methodology. So it's not only displaying results, but it's also about continuously monitoring which are the current key enabling technologies and the future enabling technologies. So with this, I hope I could give you a good impression about our products and services. And I'm very much looking forward to answering them. The questions are started. Sorry for that beforehand. Thank you very much.
Really interesting. Thank you, Dr. Stadelbauer. So I'd like to encourage everyone to please not hesitate and ask your questions in the chat box if you have any. To give us a short summary of what has been presented so far, we have my colleague, Mr. Alex Arcos. He has a degree in economics and is currently working as a communication and project officer in EURADA, thanks to a grant of IVASE, which is the Regional Development Agency of Valencia. Alex, the floor is yours.
Yes, you can see. Okay. Well, in my view, the regional analyzer developed by the team of Techmeter is a great application for RDAs. Smart specialization, as everybody knows, is a really important topic for regional development agencies. Even before coming to EURADA, it was introduced by the people of IVASE, the Regional Development Agency of Valencia, to the concept, and thereafter has been ubiquitous, since it's so important for the future performance and competitiveness of the European regions. Sometimes we hear some critical comments about the lack of dynamism of the public sector compared to the private sector. And I believe that initiatives such as the one presented in this webinar are crucial to help the public administrations be more efficient, more effective, catch up with private sector innovations, and in the end offer better services for their citizens. And this is why EURADA supports and encourages the adoption of cutting-edge technologies by its members. Actually, we participated in a project called Oasis that use big data to help RDA segment and support innovating SMEs. The regional analyzer not only provides an updated picture of the smart specialization process situation of a certain region, but also allows the user to compare the performance indicators with those of other regions, and also allows to receive customized recommendations to improve the situation, to improve certain areas. From this threefold function, the most interesting thing for me is possibly the possibility to benchmark one's situation, one's indicators against those of other regions, because we organized in November of the past year a workshop for regional development practitioners along with the Commission around the topic of the creation of a united of a united innovation ecosystem in Europe by connecting all regional ecosystems. And the Commission wanted to know which were the main bottlenecks, necessities, or problems that those practitioners had experienced in the development of their own regional ecosystems. And the thing that those regions that were still in the first phases of that were still in the first steps of the development of their own regional ecosystem was information sharing, was best practice sharing. And I think that it's a good starting point to have to know, as the regional analyzer of Techmeter allows you to know those areas in which you are not meeting the expectations, and at the same time know which regions are the top regions in these areas, so you can start looking for more specialized literature or contacting the right people. So yeah, to summarize, I will end up saying the same as at the beginning. I think it's a really useful tool for European regional development agencies.
Okay, thank you, Alex, for your insights. To further add to that and to give us the perspective of S3 professionals, I'd like to introduce our next speaker, Mr. Roberto Paras. He is an expert in innovation, regional development, research, and innovation policies. He has been working in EVASE, which was the Regional Development Agency of the Valencian region, since 1990. He has been responsible for programs to promote in-company training, grants for research and innovation projects for companies, coordination of the regional network of RTOs, and since 2013, he has been in charge of design and implementation of the Valencian Regional S3. Mr. Paras, welcome, and I turn the floor to you. Yes.
Hello, thank you very much. Very impressive work, Manfred. I would like to thank also EURADA for the opportunity to give me to express here my opinion. As a practitioner and representative of a development agency that has developed and it is involved in the planning of a smart regional specialization strategy. Any help in tracking our performance and guiding our reformulation of the strategy is always welcome with great expectation. And the main reason for this expectation is no other than how complicated it has been for us so far to carry out the monitoring with certain guarantees of the validity and reliability of the results. The greatest difficulty is for us, without doubt, to know to what extent the metrics we are applying offer us real information on the effects of our intervention measures, or on the contrary, if we are just contrasting situation of the environment and trends that are more linked to the global situation than to our local political action. So your tool, Techmeter, presents us a selective and practical understanding that, of course, I think makes courageous decisions when you choose where to put the focus of analysis. You show us how deep and far we can go with this kind of analysis. Furthermore, I understand it that it's a proactive tool, which does not limit itself to a fixed photograph of the current situation, or even to a continuous monitoring of comparative evolution, but also proposes a specific benchmark and improvement actions according to the evaluation of the information that it analyzes. So I think we could congratulate you and your team for your exceptional work. I like it very much, really. I believe that the initiative deserves our attention, but we are still left with doubts about the basic premise of your application. That is big data analysis of patents and inventions. That's true. Protection, commercialization, and sharing of intellectual property is at the heart of innovation. And unfortunately, except perhaps for trade secrets, IP is documented publicly since lots of years ago, maybe since centuries ago. Lately, public IP databases are growing in coverage and openness and services, and they are increasingly available for complex analysis. But what I think is this information enough, especially in low technology intensity regions, where the cost of protection of knowledge significantly reduces the low added value of our innovations? I think it's not a matter of number of documents. You said 90 millions, but of significance of some for some of our regions of this number. I wonder if we have access to a huge amount of increasingly higher quality and more open and better interlinked information on, for example, publicly funded R&I projects and activities, or the registry of RDI stakeholders and networks, investments, infrastructures, people involved, company results. Can we reasonably be confident that the information on patents and inventor relations and trends are significant enough? Obviously, I respect the business objective of a tool that requires, above all, efficiency. But I think that I cannot leave to wonder myself if we can use your excellent conceptual framework with other accessible information components. So I think that the value of information will be multiplied exponentially. It will probably improve the accuracy of the results in regions that don't use patents a lot, with productive structures less based on medium-high technological level products and services, such as mine. To give you some ideas, perhaps I can suggest to explore also intellectual property databases on trademarks and designs. And also, if we could add the info on R&D and innovation grant managing bodies at regional, national, or European level. And finally, lastly, I think that we need also to manage in the regions information on effects or impact of knowledge transfer. For instance, how did the business models change? Where new products, services, processes are created? We know we need to know if new marketing approaches are adopted. And a last remark, I think that we must consider for these times we are living now. Indicators on innovation and technology transfer should also relate with EU societal values, sustainability, inclusivity, employment, beyond just innovation and competitiveness related metrics. Okay, thank you very much for your attention.
Thank you, Mr. Paras, for those remarks and insight. Mr. Stadelbauer, would you like to perhaps respond to the questions presented by Mr. Paras?
Yeah, thank you very much. I need to think about the last point in particular, because that's a completely new dimension. The kind of, formally speaking, kind of weighting factor in here. Introducing, I mean, this I cannot answer on, but this is extremely stimulating what you said, that sustainability and social values should be somehow represented, because in fact they are not at all, and I can fully follow. But I particularly thank you very much for your comment on combining patents and literature which are output variables, which is one output variable with other output and potential input variables. And this is something, and that's, by the way, the reason why I've used the CPA terminology for the case study, because it depends on the granularity of technologies to look at. But if we stick to a very high level view, namely technology areas like I've shown before, then it's of course possible to link that with maybe grants, because we always need the data on this in a comparable structure, or I need to be able to make tables, concordance tables between the different terminologies. But what's very valuable in my opinion is first the input, of course, how many fundings are given and so on, but also further output variables, like for example exports. And because we've done some studies on that we can see that it's a matter of different timescales. The patents do play a role in a certain phase of this innovation technology life cycle, and they are fairly at the beginning there's certain the funding and the research done. But then the first publication is typically a patent, and some 4 years later, we see exports growing. So that's basically the pattern. And of course, it would be, I mean, first of all, it is possible, and secondly, I fully agree that this makes it even more robust to have not only this one metric, but to combine it with input and output variables. I mean, I would be more than happy to develop such a system, putting together this information, because I totally see the point. The thing I've shown you right now, this demo, that is only building on patents. What we typically do is that we refine it with publications, but we can also, of course, add some economic data, and maybe also some value data, value in terms of sustainability as a keyword. So thank you very much for these comments.
So now we have some questions from our audience. How could we use in practice the benchmark with other NUTS2 regions to establish the priorities of the smart specialization? In the example of Hamburg, does it mean that we should invest more in pharmaceutical than in coal or furniture?
I would like to go one step back before answering this question, because I wouldn't answer it so straight, because it's not probably it's not a question of investing in pharmaceuticals or other technologies, but more in how. Because apparently there is a local strength in Hamburg. I mean, just the rationale why I'm saying that. If we go back to the analyzer, to the overview picture of Hamburg, and pharmaceuticals was straight in the middle. So what one can say about pharmaceuticals is that there is an industrial output, a significant industrial output, and a significant academic output. So this is a strength of Hamburg. We can also see it from the benchmarks. Hamburg had a good benchmark and so on. So we know this is strength. The question is how to handle it. And one of the approaches from the technology network is to match this strength with emerging technologies arising to create some momentum. Why is it? It's attractive for both sides, by the way. It's attractive for the organization or the region which has competence in this emerging technology which can be linked, and it's of course of value for Hamburg because it would gain for pharmaceuticals. So we would rather look for the, since we don't have to strengthen academia and we don't see a rationale to strengthen industry. It's from this picture, because this is nicely in balance and also the performance benchmark are fine. When you look at pharmaceutical products, it's more about creating an ecosystem which is rich of matching key enabling technologies for the future. It's more about making and keeping it fit for future. That would be when I look into pharmaceuticals, the answer from this picture. The comparison to coal or furniture, let me see if I can find the coal here. So for furniture, the picture is different because we see some industrial strength here. That's the point here. That's why I couldn't see it because it's on the left axis. But we have very little output, we have actually no output from academia in this region. So this could be, if furniture is a relevant topic from a strategic perspective, then the recommendation from the dual strength analysis would rather to keep it supported from industrial research. Now it always sounds a bit trivial because it sounds like low tech, but in fact the furniture which creates patents, this kind of furniture is highly functional, and there is a lot of and I'm absolutely sure there's a lot of technology in this kind of furniture which is described in here. I mean, we've also seen it from the SMEs like Airbus and so forth. So this is not a normal chair. So it might be valuable to consider where to link furniture in the academic environment, because apparently this is a strong potential for Hamburg, at least, to get it supported from universities as well. So completely different strategies I would derive for those technology areas based on the map we've seen.
Okay, so linked to this previous question, do you have any examples of policy-making stories based upon this tool?
Yeah, I mean, yes. What is very successful is to identify in a very early stage cooperation universities, and these are the regional initiatives. They from regional development agencies. In Austria, this is business up. In Upper Austria, this is, for example, business Upper Austria, but also from the chambers when they team up regional companies with universities, and this is extremely successful because with our system, because they organize their initiatives regionally. They want to select a certain target region, and in this certain target region, they need to have organizations to specifically team up. And that works very, very nicely. And we've got a lot of positive feedback about the travels, for example, they organize with companies to these institutes, which are highly specialized. And this literally helps the planning, because the organizer just needs to click on the certain region, which has been identified beforehand, and then a list of innovative companies in the relevant field and of the university appears. So this is one useful benefit. Another very useful benefit is when it comes to exports. I need to explain that when it's not, I mean, this kind of triggering cooperations, interdisciplinary cooperations, is often also, I mean, in Austria at least, also done by the chamber looking into exports. They also organize some trips abroad. And on the other hand, there is a network of offices around the world which invites Austrian companies, for example, to come there. And it helps also these offices abroad to identify those local companies which have matching technologies on an organizational matching technologies with Austrian companies, because that's where the customer is, and to create this link. So to organize fairs or any kind, I would say, to enable matchmaking. This is a perfect tool, and we have a lot of references in this field.
All right. And when it comes to emerging technologies, could you please indicate how you identify them? What are the criteria? Is it fast growth of an unknown technical?
Yeah, I will take. I need to take more time on this particular chart, and maybe as an introduction, I go back to my patent here. So I want to explain that precisely. So give me 2 or 3 minutes to answer that, because it's not so straight. One patent out of, as I said, a lot, connects different technologies. And these technologies are mentioned in the title. So this CO9J something stands for some very specific technology. And this CO8L23 stands for a very specific other technology. So we have one patent in front of us out of 90 million, which all more or less fulfill this criterion. We have one patent from which we know that it connects technology 1 with technology 2, 1 with 3, and so forth. So there are 9 technologies just in this particular patent which are connected, just as an introduction. And we know when it was published. It was published in 2005. More I don't need for this. I can plot all the CO9s and so forth, which are, and where we have 240,000 technologies like this CO9 J900. I can plot these as dots in a network. And I can connect with every document. I get connections between the technologies. The one patent I've shown before might only connect a small area here, but if we look at all the 90 million documents, we get an extremely dense network of connected technologies. Just as an introduction, it doesn't help at all. Well, yes, I mean, you could see historically which technology is central in such a network, which is nice to know. But when we look into current key enabling technologies and future enabling technologies, then we need to demand that there is strong dynamics in this technology combination. So actually, just look at the connections between different technologies, and saying, for example, the connection of CO9, the first one and the second one. Let's just focus on this this technology combination, and we would like to know: is this something new, or is it something which is trivial, which is obvious? I mean, there is a lot of technology combinations which are obvious. So we go back in history and look at the dynamics of this technology combination, and especially, and we demand that it's new in the past 8 quarters, sorry, in the past 2 years. And the reason why we look into the past 2 years is because we've measured that the exports are starting to grow 4 years after patents start to rise. So that's why, and we want to keep some information benefits, so we don't want to look at the past 4 years, because that's point in time where we already see exports growing, but we want to have some information lead time, and in this case we still keep 2 years information lead time. So we look at the past 2 years and demand that the number of patents published in those 2 classes is growing exponentially. That's our criterion. And if we do that for these 28 or 29 billion technology combinations, then only 7,500 connections remain, which fulfill this criterion, that in the past 8 quarters, they grew exponentially. So this I mean, that's the only reason why it's working at all, because the complexity can be reduced so significantly And that's how we determine the exponentially growing technologies. That's all at this stage. But then we do something more. Then we plot this picture. So what's shown here is only those technologies which show exponential growth in combination with another one. And over that, we do a network analysis and do a clustering. Then we have some 500 emerging technology clusters in here. And within those clusters, you can see central technologies. And those central, the big ones, and they are big because they have the highest network density in this technology network. These are the key enabling technologies of an exponentially growing technology cluster. And so that's the answer on the question how we determine it. So we look into try to make it in one sentence. We look into the past 2 years. If we find technology combinations in literature which are not only growing exponentially but which are also new, then we put it in a basket, and this basket we sort so that we only keep up 500 clusters with individual key enabling technologies in the center of this technology cluster.
Okay. With all this data and information, does Techmeter take into account ethical considerations in their work and public engagement, which are two of the keys of the European Commission's responsible research and innovation agenda? So, for example, were the interdisciplinary cooperations with the tobacco industry you mentioned about innovations for making the products less harmful? And to what extent are the societal views on these cooperations taken into account?
I mean, the second question, the societal aspects, I can only thank you for the question. I mean, not at all. And I need to think about that because I don't have an answer to that, but I agree that it's important. That's all I can say at this stage. And I also have a gut feeling that it's possible to integrate it. Very thrilling question. I have a couple of ideas, but no solid answer right now. The other point is the topic area of startups. Here, in the metrics we've seen, it didn't play any role if the output was generated by a huge company or by a small one. Still, this question is addressed by our methods. And it's an interesting one. It's not included in the demo I prepared, but it's generally possible to do, based on our patent data, to do a mapping of highly specialized companies. I mean, it's obvious. An industry giant, for example, might have an awful lot of patents in a certain specific technology area, but an agile company might have a small number. But the difference between the giant and the small agile company is the overall number of their patents and the degree of their specialization. So what we can do at an organizational level, we can calculate the degree of specialization of companies and say, well, we do have on two axes, imagine a portfolio on two axes. The one is the specialization and the other the overall output. And the industry giant might have a big output, but it will not have the specialization. So it will be on the left in this diagram, whereas a startup, for example, which already has some outputs we detect here, would be highly specialized. This is probably only a part of the answer. The part which valid for those which have patents already. If an startup doesn't have, is in a very early phase and doesn't have any output metrics yet, I would see the value of these tools rather in providing a vital environment for those, to show them where are the top partners, where are the, for example, emerging technology, the agile companies which already published something. So to do this kind of technology intelligence with them and to assess their project based on their environment, then including them in the metrics already. But this comes a little bit together with alternative information sources which can be fed into such a portal. Maybe there is a need to include these early structures, these young structures as well, which don't necessarily have some measurable outputs yet.
Okay, we have one last question. Where can our audience find more information about price and subscription models? And maybe to add to that, normally, how long would it take to create this database or set up this program for a region?
Yeah, as typically we combine, at least at the beginning, consulting with the portal, because there is a lot of, first of all, very often there are some specific questions which can be addressed, and the portal can be tailored, and also it's about, so to say, training. I mean, it's very straight and easy to operate, but still it needs some interpretation. And so we like to combine it with consulting, and this is in the order of, I mean, it's very hard to say because it depends on the how much time we need to define the topics. So if it's a more generic set of topics, then we have set that up in a month or so, including the consulting and the handover and so forth. And then the fee, the regular fee, so to say, is more or less just the updates every year or every half year. It depends a bit it always depends on the specific questions. It might be enough to update the data cube once a year if this is the frequency, so to say, of initiatives and priority setting and strategic, because it needs to match, the frequency of updates needs to match with the frequency of the strategy process. And this can be only once a year, or it can be twice a year, it depends. And these updates are substantially easier, and maybe a thing of 2 or 3 weeks, and then it's up to date again.
Okay, and with that last question, I believe our session has come to a close. So on behalf of EURADA, I'd like to thank once again Mr. Stadelbauer and Mr. Paras for sharing their expertise and knowledge on today's topic. And I'd also like to thank everyone for joining us today and for contributing your questions and ideas on the topic. We hope to see you again in one of EURADA's future events. So thank you, everyone. Have a nice day.
Thank you.
Thank you.